I've still got up on the board here our basic epsilon delta definition for a two-sided finite limit of a function. Because with all other limits, we're just making some modifications to that basic model. So in the last video, we looked at one-sided limits. Here, we're going to look at infinite limits. So I've drawn a picture here of a function where this is true, that the limit as x approaches a of f of x is infinity. Now that's going to be a bigger change than a finite one-sided limit because infinity is not a number. And so you can't get close to infinity. You can't measure the distance between where you are and infinity because infinity is always infinitely far away. So when I'm claiming that my y values go to infinity, I'm not saying they get close to infinity. What I'm saying is they're getting big. And they're getting big in the positive direction. Okay, so if I look at this and I compare it to my basic model, what I'm saying about x is still the same. X is getting close to a number. The difference is in what I'm saying about y. My y values are going to infinity. They're getting big. So remember we said that our blanks, we start and end talking about y, because the limit is all about what are the y values of my function doing. The middle two blanks, we're talking about x. So those blanks are going to be the same here. I'm still going to have a delta bigger than 0. That's going to be my standard of closeness for my x values, such that if 0 less than absolute value of x minus a less than delta. This inequality says that x is close to but not equal to a. But for the y values, I'm going to have something different. Instead of having a standard of closeness, because we're getting close to a particular number, I'm going to have a standard of bigness. This is saying this is getting big and positive. So I'm going to say it counts as being big if it's above a certain height. So I'm going to say, let's just say we've got m. I'm going to use a capital letter M as my standard of bigness. So, for every m bigger than 0, no matter how high you set that bar, we really are sort of setting a bar so that we're saying above that bar counts as being big in the positive direction. No matter how high you set that bar, okay, I can find a delta so that if we're close to delta, now what I want to say is that my y values on my function are big, where m is my standard of bigness. So that's going to be that f of x is bigger than m. Okay. Notice there's no subtraction here. There's no absolute value. It's just that thing is bigger than this number, which I'm viewing as my standard of bigness. And if we look at the picture here, so I drew in m at this height. Let's just see if on the picture we can find what our delta would be. Now, I'm not going to be able to get a numeric value. I'm just going to graphically see where it would be. But I can see that my function crosses this line m and enters the big zone here and here. So if I just follow this down, that's going to give me an x1, and this would give me an x2. Okay. As long as my x values are in between these two numbers, my y values will be above m. Okay. Now, if I want to describe that in terms of one distance, I can see that the distance on the left is smaller than the distance on the right. So if I take that distance, I could go that far to the right, and if I stayed within those bounds, my y values would be above m. Can't do that with the bigger distance, because if I go the bigger distance to the left, I'm hitting a point where some of my y values are below m. So my delta would basically just be that horizontal distance between x1 and a. So in this case, it would be a minus x1. Obviously, if I had a formula, I could actually calculate what x1 was and calculate that distance. And that's what we'll do in the next video. I will just point out that in the Canvas check-in assessments, you will work through figuring out what's the formal definition for a limit as we go off to negative infinity. Again, you'll basically be replacing epsilon, which is our tolerance or our standard of closeness for the y values, with a number, in this case it would be a negative number if we're going to negative infinity, that's a standard of bigness in the negative direction. Okay, so you'll be working through that. And we can mix and match. We've certainly seen sometimes we have a one-sided infinite limit. So we can put all of the pieces together. So as you're working through these definitions, don't just sit down and memorize them, because I could ask you for any combination of things. I could say, give me the epsilon, or the formal definition of the limit from the left being negative infinity. So you're having to work with one-sided limits, and you're having to work with infinite limits. You don't want to have to memorize every single combination. You want to understand it. And generally, if I'm asking you for the definition, I would give it to you in this form and just ask you to fill in those 4 blanks. So you're always looking at, do I want a standard of closeness or do I want a standard of bigness? And then what inequality tells me that I'm meeting that standard?